Danger in the Darkness, the weird story of rogue planets. Written by Rod Pyle, read by Rod Pyle. There are worlds that are unattached to any stars and are free-floating in space. One of the questions that comes up is this: if one of these rogue worlds were to approach our system, what would happen? Says Dr. Rosalba Perna, a professor at Stony Brook University in New York, in a conversation about rogue planets that drift through space, free of any solar system. The new data came from a survey of Jupiter-mass binary objects, or JUMBOs, by the James Webb Space Telescope. Some of these rogue planets are more Earth-like, while others are more Jupiter-like, she says. But the ones that, for recent surveys, seem to be more abundant are the tiny ones. So if a small rogue world was to come close to our star system, it wouldn't be as dramatic as if it were more like a Jupiter-mass one, and the probability that a free-floating Jupiter approaches our solar system is not very high. We're not in a super dense stellar environment, unlike some other star-forming regions that are very, very dense, and where there's a lot of chaotic interactions and flybys which can eject planets and disrupt planetary systems, she adds. So the good news is that very large and commensurately dangerous rogue planets appear to be very uncommon in this part of the Milky Way. The other good news is that it appears that planets are much more easily kicked out of orbits at the outer reaches of a system, well beyond the orbit of Pluto, scratched too dangerous from the skies in the earthly neighborhood. However, if a star was to pass nearby, the Earth could be ejected, or even if it wasn't, it could create dynamic instability within the solar system. If that happens, the planets that would suffer the most, and would be most likely to be ejected, would be the lighter ones, she notes. So humanity doesn't get off scot-free after all. But we're here to talk about rogue planets, errant bodies that can be seen coming a long way off. But the smaller rocky ones, traveling solo through the darkness of interstellar space, would be much harder to spot. Perna's work is primarily focused on how rogue planets are created, that is, how a planet gets ejected from a star system. A lot of this planet bullying appears to take place early in planetary system development. If we look at the surface of planets like Mercury, it has a lot of craters, and these are signs of past bombardment, explains Perna. So we know that there was a lot of chaos, and the planet-to-planet dynamical interaction became important. If you have a giant planet like Jupiter approaching a smaller one, the smaller one can get kicked out. This is something that theorists have been able to reproduce with numerical simulations in which they simulate the formation of systems and see some ejections, preferentially of smaller planets, she adds. The James Webb Space Telescope observations were focused on particularly star-dense area of the Orion Nebula, the Trapezium cluster, which is some 1,344 light-years away from Earth. While the research team is still awaiting final confirmation of their work, dim colors observed by the telescope could be either planets or partially obscured stars. More than 500 renegade bodies were spotted in the survey. In a region such as this one, these interactions are apparently not uncommon. With stars packed shoulder to shoulder in relative terms, she says, as a star passes by, which happens with relatively high frequency, there could be an ejection. The star is basically giving a kick during the process of this dynamic interaction. Quite often, single planets are ejected, but ever so often, if the orbits of two planets or of the two outer planets are relatively close by at the moment of interaction, it could result in a binary ejection of two bodies. And that's where the story gets to be a bit unusual. In their study, 40 of the objects spotted were binary pairs, much higher than would have been expected. The reigning theory states that the reason for the unexpectedly high numbers of binary pairs of rogue planets may be the result of worlds in relatively close orbits. When one planet is affected by stellar forces, it pulls the other nearby one along with it as it's ejected from the star system. This would include proximate moons. But in our neighborhood, roughly in the middle of the Orion arm of the Milky Way, we can rest relatively easy when it comes to any direct danger to us from a rogue planet. This part of the galaxy is pretty sparsely populated. Looking beyond any dangers to our own planet, might rogue planets have other uses besides being dead masses of gas or rocks drifting through the darkness of interstellar space? Could these drifting bodies be home to civilizations like our own? They would have to have their own way to produce energy, Perna says, because we rely on the sun for light and for energy. They would have to be super smart in order to be able to live without a source of light, and that's a big challenge, she notes. However, since these objects sometimes occur in pairs, and one partner in that cosmic dance can be a brown dwarf star, might the tidal flexing caused by the dwarf's gravitational field be sufficient to generate heat within the smaller partner? That depends, Perna says. A brown dwarf is something that's hot for a period of time, then cools off very quickly because it doesn't have a long-term source of energy, unlike our sun. So if the paired planet is at the right distance for a period of time, we might have the right conditions, but they would not be as long-lived as for the Sun, which will last billions of years. So, whatever life forms originated there would have to get their evolutionary act together pretty quickly in terms of galactic timescales. Of course, people are most interested about their own welfare. What might happen to an alien species dwelling in an ocean on a small, warm world that's being dragged through space by a brown dwarf is fascinating, but what of the future of our own planet? In the case of our Sun, Perna says, it will evolve into a white dwarf, and that's a slower process. But at some point, due to the evolution of the Sun, the Earth will get very hot, though there won't be an explosive event like with larger stars that go supernova, Perna adds. However, if a star were to pass nearby, the Earth and probably our Moon could be ejected. If that happens, the lighter planets like our own would suffer the most and be the most likely to be ejected. In sum, Earth could itself become a rogue planet covered in buildings demolished by planetary upheaval and lying in frozen ruin. In the near future, when the new Nancy Grace Roman Space Telescope is launched, the study of rogue worlds will accelerate. While a number of exoplanetary systems have been identified by microlensing, which uses the mass of a large star to gravitationally magnify another object much further away, the telescope will carry out a specialized survey of the galactic bulge, a target-rich environment, using the technique. Since this telescope will, like the James Webb Space Telescope, be capable of operating in the infrared spectrum, it should spot exoplanets and other stellar objects that traditional methods like stellar transit, where a planet moves past a star from our point of view, and radial velocity measurements, the tugging on a star by a planet too small to be visible, cannot. Microlensing will allow detailed investigation of extremely distant objects, including rogue planets. The launch for the Roman Space Telescope is planned for 2027, and we'll be sure to let you know if something is spotted coming our way.